Meanwhile, it gets started. We have to. Okay, so welcome back to the channel, Glorified Education. Let me just start the video and just a minute. Let me just make the mode to the teaching mode, and that's final. Yes. So we were discussing about the questions. Basically, we have discussed the 5 question of the this is called as limits starting. So we are going to start further. This is the 6th question. Let me just erase this one. Yes, this is the 6th question. Now in this question, what we are going to do, see, we can see if I put pi by 4 here. So on putting pi by 4, I'm basically getting this is 0 by 0 form. So it's better that I apply L hospital. So it becomes 0 on applying L hospital. Cos theta will become sine theta. In fact, minus sine theta. That's why it's become plus. For minus sine theta, it will be minus cos theta. Fine. Upon 2 into 4 theta minus pi. Even if I put pi by 4 again, it's again 0 by 0. Let me differentiate again. So it will be cos theta will be sine theta will be cos theta. And here I will be getting the sine theta. And denominator it will be 2 into basically 4. So 4 here, and if I put 1 by root 2 plus 1 by root 2, that will be a 2 by root 2. So I'll be getting 1 by 16 root 2. Basically B is my answer. The question of limits are short type. We can usually do it in the 1 or 2 minutes. The basic thing is that we have to keep our concepts clear. Now let's move to the another question. So this is x sin x, x minus cos x is equal to. Now if I see, basically infinity by infinity form is like there, because sine x infinity is basically a, if I talk about sine infinity, it's basically a value between minus 1 to 1. Value between minus 1 to 1. And similarly cos x is minus 1 to 1. So it's the x only which decide that our numerator is infinity as well as our denominator is infinity. So let's see what happen if I take x common. So x common, if I take, it will become 1 plus sin x by x upon x 1 minus cos x by x upon root 2. Now this x and x will cancel out. I have 1 upon 1 plus sin x by x and 1 minus cos x by cos. If I apply infinity by infinity here, so sin infinity will be a fixed value, but x is infinity. So 1 like finite over infinity will be 0. So this basically tends to 0. Let me change color to show this one. This will basically tends to 0, and this is let me show. This will be basically this is also 0. Yes, because again cos x is also between minus 1 to 1. That will also 0. So if I put that, I will get 1 as my answer. So 1 is my option B. Now let's move to the other question. What is the value of the limit x tends to 0 to 1 minus cos x over x square? So here I have various approach. I can convert into the sign also, like 2 times sine square x by 2. And 2 is already there. So 2 sine square x by 2 upon x square. Now it can be divided by 4, multiply by 4. Now this basically is nothing but tends to 1, because if I take x by 2 whole square, let me just take one more step. So 4, see this will cancel out. Let me cancel just out, and let me just take one more step. So it will be sine x by 2 and denominator will be x by 2 whole square, and it is whole square also. You just erase this part. So it will be basically nothing but sine of x by 2 whole square. So it can be like sine x by 2 over x by 2. So it also tends to 1. If I take to 1, so 1 square is 1. So my D option will satisfy. Now let's see another question. So this is sin x minus tan x over x. Sin x minus tan x over x, x tends to 0. So it's very easy. It will be sin x by x minus tan x by x. So both one tends to 0. 0 by 0 is becoming. So this is also 1. This is also 1. So 1 minus 1 is basically 0. So my answer is 0. Now let's move to the question number next. So next is a series question. Now let me just correct the question because the question is not looking correct. the denominator, let me just write the question. The question is basically limit n tends to infinity 1 plus 2 plus 3 so on up to n over 1 square plus 2 square plus 3 square up to n square. So this is basically my, I could say, the question is, so if I solve upward, my upward will be n into n plus 1 by 2 and my denominator will be n into n plus 1 by 2, sorry, not by 2, will be by 6 in fact, and in fact few more terms. So n into n plus 1, just a minute, n into n plus 1 into 2n plus 1 by 6. So if I see the degree of the denominator, it is 3 because n here, n here, and n here, and degree of numerator is basically 2. So the answer will be 0. When we have degree of numerator, degree of denominator greater than degree of numerator, my answer will become 0. But then this is the next 5 question. Next 5 question we see in the next class. Till then, keep learning and goodbye.